All right, let's get started. So today's lecture is on, excuse me, SQL schema design. So this is something that I know several of you have encountered on the phase 3 challenge, and it's part of the phase 2 curriculum, of course. So we're going to be focusing today on like how you go from just a general description of a problem or an application and like figure out how to design your schema, what tables, what columns, that sorts of things. And we're going to kind of work through an example. So please stop me with questions for clarification or anything else. I'll try and keep the chat visible, but also just unmute and shout at me as usual to get my attention. Let's get going. So SQL schema design. So we're going to work through, for explanatory purposes, kind of a sample scenario. So let's say we're building a blog application, right? We're trying to figure out how to structure our database for our blog. Specifically, let's say we're building a law blog for Bob Loblaw's law blog. So what kind of things are we going to have in this type of application? So here's a kind of a description of the thing we're building, just in prose, right? So it's a blog that will contain posts on legal topics. Visitors to the site can create user accounts in order to leave comments on the posts. Some of those users will also be authors of posts. And authors will have a 1-paragraph bio. Posts can have multiple authors, okay? So how do we go about figuring out what kind of database we're going to need for this? So the approach that I like to use that you'll see recommended a lot is to look for nouns. Look for nouns in your application or the description of your application, right? Those often correspond with your tables. And the tables that you're going to need are the objects that you're going to need if you're building an object-oriented system. So let's look through this again and look for like interesting looking nouns. So our blog's gonna have posts. So we're probably gonna need a posts table, right? Looks like the blog is gonna have comments as well. That's another good signal. And we have this thing called a user account. So we know we're storing some information about users, right? Well, they'll at least need email and password. Let's see, posts can have multiple authors. I just realized that these two slides are not in sync. This description is a little bit different than the first one. That's what I get for making improvements as I go. So posts can have multiple authors, and posts can be associated with a single category. I think the first slide said something about authors having a bio, so we're actually getting rid of that. But posts can have categories. So it could be like a criminal law or personal injury law or that sort of thing. So what I'm seeing here is I'm seeing posts, comments, user accounts, categories. Those seem to be the big nouns, the big things in our domain that we're going to need to model and probably store somewhere in a database, right? Posts, comments, users, categories. So that's a great start, right? And got a pretty good idea here. We're going to need at least these 4 tables. So let's look at post, right? What is a post going to need? Probably eventually you would need more columns than this, but minimally, right? We know that a post is going to have some big blob of text that is the content of the blog post, and an ID for the table to uniquely identify it. And we could probably think of a lot of other stuff we could add in here, right? Like the blog posts probably have a title, and they might have like a date published and things like that. But just to keep it simple for right now, let's just start with the one thing they're absolutely going to have, which is a body. And you can see that I'm naming the table the pluralized version of the noun. So it's a table that holds posts, so I'm calling it posts. You'll find different opinions on conventions for naming your tables. Some people will say, no, it should be singular. It should be post. I don't care. When I say I don't care, I mean that I don't care how you do it. I always do it this way, just because I've gotten in this habit of doing it this way. Probably primarily because when I was working in Ruby, with Ruby on Rails, this is the convention. And if you want to do it a different way, it's very painful. So I just got used to doing it this way, and it's worked well for me. But pick a convention and stick with it is what I would say. So if you're going to store posts in a table called post, then make sure all of your tables have singular names. If you're going to use plural names, use it everywhere. Just be consistent. It'll save you headaches later. So there's our post table, very straightforward. Comments is going to be similar, right? Comments also are just like some blob of text that somebody wrote to comment on a story. So minimally, they're going to need an ID and a body. Users are a little more interesting, right? So users are probably going to have some sort of username and password. In this case, we're just going to use email as their sort of username for their account and a password. Categories. So we have this thing called categories. All we really know about categories is that, posts can be sorted into categories. So the category itself, the only attribute an individual category has is a name. So that still leaves us with figuring out how to relate all of these different things, right? So posts obviously have some sort of relationship with comments and with categories. Users have this relationship with posts and comments, and that they can write comments, they can author posts. So there's a handful of different types of relationships that are going to, that we're able to model in a relational database, an SQL relational database. There's many-to-one relationships, one-to-many relationships, many-to-many relationships, and we've got some examples of all of those in this example, right? So a post has this relationship with category in that you have many posts that are all going to be connected to one category, right? You have lots of posts in each individual category. But based on the specs we read earlier, posts can only be in one category at a time. And then you have this relationship from posts to comments, or from comments to posts, depending on the way you look at it, where one post is going to have many comments, right? Or many comments are going to be associated with this single post. So we have like a many-to-one relationship, a one-to-many relationship. Users and comments have a similar relationship there, where many comments can be authored by a single user. And then we have a many-to relationship between posts and users. If you'll remember in that description of the problem, we said that posts can have multiple authors. So you could have like several people collaborating on writing a blog post. So one post can have many authors, and one user can author many posts. So that's our most complex sort of many-to-many relationship there. So, and this is kind of a good idea, like, especially if you have a little bit more of a more complicated system, to like get a piece of paper and a pencil out and sort of map these things out, right? Figure out, okay, what are my tables going to be? And then if you need to draw some lines to figure out, okay, I got a one-to-many relationship here, I've got a many-to-many relationship here. Like this sort of like drawing things out can be really helpful just for you to get your head around the problem before you actually start writing SQL and like building these relationships into your schema. So let's look at how we would model some of these relationships in our tables. So a post belongs to one category, right? So it's a many-to-one relationship. And the way you're going to model a many-to-one relationship is put an ID, put a reference in the table on the many side to the table on the one side. So in this case, we have many posts belong to a single category. So we're going to go into the posts table, and we're just going to stick a category ID column in that table. And that allows us to take any post and associate it with a single category. right? And each post can have its own category ID, so that allows us to point many posts at a single category. If we look back at the diagram here, you can see this arrow has a direction, right? Many posts to one category. So a way to remember this is if you have an arrow sort of pointing out of post going to category, if you have a many to one relationship, the table that the arrow starts in is just going to have an ID that is pointing towards the other table. So in this case, we have a category ID in post that points to a row in the category table. And that's how you would model a many to one relationship. And again, a note here on just like conventions for naming. What I've done here is I'm just calling this category ID. It's pointing to the ID in the categories table. So I'm singularizing the category, the table name, and then underscore, and then the column name in that table that I'm referencing. So since I'm referencing the ID column in the categories table, I'm calling it category ID. And that sort of semantically makes sense, right? Because this is going to be the ID of a category. So it makes sense for it to be singular. And again, that's just a convention. I'm probably more opinionated about this one. I can't think of a lot of different ways that you would do this. You could call this categories ID, but that just seems confusing to me because it's the ID of a single category, not of a bunch of them. But again, pick something that makes sense to you and just stick with it. It'll save you a headache and confusion as your schema gets more complicated. So there's our first many to one relationship. So now we have this comment to post relationship, which is a sort of a one to many relationship, right? One post can have many comments. So one post has many comments. So if we try to add something in the post table here, we're going to come up short, right? Like what would we add to the posts table to link to many comments, right? You could, it's not really a good way to represent that, to represent like a list of things in a column in SQL. There are some ways you can do this in Postgres, but it just gets messy. So really what we want to do in this case, where we have a one-to-many relationship, one post has many comments, is to just flip it around. A one-to-many relationship is just another way of looking at a many-to-one relationship. So if you think of it again as a many-to-one relationship where a comment belongs to, and I'm just, oops, sorry. This slide just has the wrong title. Many-to-one, comment, no. Many comments belong to one post. Oh, no, that's not what I wanted to do. And we're back. Okay, so many comments belong to one post. Think of it as a many-to-one relationship from comments to post. And then we know how to do that, right? We've got many comments all pointing to the same post. So we just add a post ID in the comments table. And say that it references posts ID. Any questions about this stuff before we go on? About like many-to-one relationships or the stuff that I've gone over so far? I meant to stop a little earlier. Nobody
So we're in the comments table, and then you're saying that the post ID, this last line, that's referencing another table called post?
That's right, yeah. So we're adding an attribute to our comments called post ID that's going to hold an integer that is the ID of a post in the posts table.
Gotcha.
Does that make sense?
Yes.
Okay. And we'll go through some like concrete examples later, and maybe it'll help kind of ground this when we see like actual data. Yeah, but the idea is that this ID is just, it's a reference to a row in the posts table. It's just saying, okay, these comments are all associated with post number 5, right? And if we go in the posts table and look for the row where ID is 5, we'll actually be able to get all the information about that post number 5, post with ID 5. Yeah, so there's a question in the chat, is this to simplify joins? Yeah, having the IDs in here is specifically so that we can join tables together in queries, so that in a query we can sort of relate the comments for a post with the post itself. And we will be using joins to do that. And I've got some examples of that later on. So yeah, this is going to set us up to be able to do joins easily-ish. So what other things have we not done here? So we've got another one-to-many or many-to-one relationship. So this should start to be really familiar, right? We've got many comments that are attributed to a single user. And so we're just going to add, just like we added a post ID to comments, we'll also add a user ID to comments that will give us a reference to the user that wrote these comments. So again, comments written by some user with ID 12, then we'll just put 12 in the user ID here. And then if we, if we come across this comment, we want to know what's the email address of that user, we'll know, oh, it's user ID 12. I can go look in the users table for ID 12 and I can find that user's email address or their other information. So finally, the tricky one. So many to many. We've got posts can have multiple authors. So we can't do this exactly. We can't come into posts. We certainly can't do that. Editing slides during the presentation. Super professional users. There we go. That's what we wanted to say. Okay, so we can't just come into the posts column, posts table and add a user ID, because a post could have multiple users, right? It could have multiple authors. So just showing one ID isn't going to be enough. We need to reference many of them. Similarly, we can't come into users. Did this wrong 2 times. Post ID, post ID. So we can't come into users and add a post ID, right? Because users can have lots of posts, right? And you could think, well, we could just add, let's add several columns in users for all of their posts, right? But you could see this could get unmaintainable really fast, right? You don't want to have post ID 0 through 100 in a user to store references to all of their different posts. And then you're going to get into trouble when your first user writes their 101st posts. Now you're going to have to come and like alter your table and add more columns, and it's just a mess. So we need something better than this, right? And it doesn't seem like adding something to the posts table is going to help us, and it doesn't seem like adding something to the users table is going to help us. So what we're going to need is something called a join table, also known as an associative table. And if you Google for join table or associative table and find the Wikipedia article on that, you'll see there's also like 28 other names people have for this. But join table or associative table are the ones that are most common. Join table is the one that I hear almost all the time. So join table is a new table we're going to add to our database that is simply there to express a many-to-many relationship between 2 other tables. So it's a table that maps 2 or possibly more tables together by referencing keys in all of those tables that are being related to each other. So what does this look like exactly, right? We have this posts and user many-to-many relationship. So the way that we're going to express that is we're actually going to add a third table that has a many-to-one relationship with posts and many-to-one relationship with user and we're going to call it posts users. So this is another convention where I'm just taking the table names that we're relating to each other and I'm just joining them with an underscore. And so what is this posts users table going to look like? It's going to have a post ID and a user ID. It's not going to have an ID primary key because really the only thing that this is holding is these 2 IDs for post ID and user ID. So I'm actually going to say that the primary key is post ID and user ID combined. It's called a composite primary key. It's kind of a primary key that has two elements in it. And I would say, don't worry if you don't quite understand like composite primary key, why we're doing that. Don't worry about it too much at this point. The main point here is that we have this table that has, each row has one post ID and one user ID. So each row in this post users table is expressing authorship of a post, right? So a single row might have a post ID of 5 and a user ID of 4. And that's basically telling us that the user number 4 is one of the authors of post number 5. And so we can add as many rows to this table as we want to express that many-to-many relationship. So let me see if I have an example of this. Yeah, so for instance, that's not what I want. Let me just get somewhere where I can write some code. So you can imagine this table having rows. So it's going to have a post ID and a user ID. Stop capitalizing things for me. So we could add a row that's post ID 4, user 2, post ID 4, user 2, and 5. So you can see how with these 3 rows, we're sort of, we're expressing that many-to-many relationship where we say this post ID 4 shows up twice in this table, right? Because it has 2 authors. User ID 3 is one of the authors, and user ID 2 is another one of the authors for post ID 4. So that's getting us the sort of the one side of the many-to-many relationship where we have one post that has many users. And then also we see down here that the user ID 3 shows up in this table more than once, right? User ID 3 was one of the authors for post number 4. And user ID 3 is also one of the authors for post number 5. So this little join table allows us to express that many-to-many relationship where we can have lots of users writing one post, lots of posts being written by the same user. And one thing I'm going to do here is I'm going to change the names a little bit on this table. So originally we were calling it posts users. But in this case, this relationship is something specific. This relationship is showing who the authors of the post are. So these user rows are actually filling a specific role, right? We're saying that these users are the authors of the they're the authors of the post, right? And the reason that I think it's important to change this name to posts authors is that we may have other associations. We may want to associate other users with this post for other reasons in the future, right? You can imagine that posts might eventually have an editor or some sort of an admin, or it could be a lot of different ways that you want to sort of associate a user with the post and put them in other roles. They're not necessarily the author of the post. Maybe they edited the post, or they proofread it, or they're responsible for managing the comments on the post, or anything like that. So what we're going to do here is change this name of this table to posts authors and call the user ID the author ID. And we'll see it's still a reference to the users table, but this gives us a little bit more of a hint in the schema as to like what this table really means. We're actually mapping posts to their author. And authors just happen to be users. Users can be lots of things in the system, but one of the things they can be is the author of a post. Any questions about that, about the many-to-many relationship and the join table before we move on to some examples? All right. Feel free to stick stuff in the chat if you think of it. And let's keep going. So let's look at actually querying this schema now. We've got all our tables defined. We've got our relationships defined. So what does it look like to actually get data out of this system? What would our queries look like? So we'll start with something simple. So if we want to just get like, what are all the comments for a post, right? You're going to have to do this every time someone loads a post page on your blog website. you're going to want to put a bunch of comments at the bottom. So you're going to need to go query the database for all the comments for a given post. And that's one of those, many-to-one relationships. And since you're loading the page for that post, presumably you probably already know what the post ID is that you're rendering. So you can run another query on the comments table and say, okay, I'm building the page for post number 3. Give me all the comments for post number 3. So I can say select star from comments where post ID equals 3. Then that'll give me all the columns from the comments table for any row where post ID is set to 3. So that's the easy case, right? We're just querying one table where we're sort of assuming we already have the post ID that we're looking for. We know what it is. We know it's 3. And we'll get something like this, right? It'll just be a subset of the rows from the comments table where post ID is 3 for all of them. And we'll be able to see the user ID that wrote each of those comments like we saw in our schema. And each of the comments itself will have its own unique ID. So the more complicated case is where we want to join tables together. And this is something you'll do a lot in SQL, and it can get confusing unless you have like a good conceptual understanding of what's going on. So we're going to spend more of our time talking about like the join queries and how we would query multiple tables at once in a single query. So let's talk about just a join in general, like conceptually, what does it mean to join two tables? So let's say I've got my comments table and my users table. So here's an example of some data I might have in each of those tables, right? I've got 4 comments here and I've got 4 users. And then of course I have this user ID column in my comments table that references users by their ID in the users table. So what a join does when we join, if we say we're going to join comments and users on user ID, what the database is going to do is it's going to go through the comments table, and for each row, it's going to look at the user ID, and then it's going to go find that row in the users table. So we're going to say, okay, user ID 2, let's go find that guy. He's over here. That's Donald. And then user ID 4 shows up twice here, right? Both of those are going to point us down to Fatima, user number 4. User number 1 at the end points back up to Sophia. So we're drawing these lines, right? We're using these links, we're using these integers to draw a line over to a row in the users table. And then what the database will do is it will create what you can think of as a new set of results, right? Which is going to look a lot like a table. That is the combination of the comments and the users table with those joins completed. So we'll get like one row back that has comment number 1, right? ID 1 for the comment. That's nice. And then it has these extra columns added, which are the matching, the attributes for the matching user row in the users table. So we'll get the email in there. And we'll see, because we had 2 comments here with user ID 4, we see Donald's email come up twice in these results because he's showing up as the email for the author for this comment number 2 and for comment number 3.
Oh, question. It says ID 4 for Donald, but I thought that was for Fatima.
You're correct. That is a typo.
Okay.
That is a typo. I don't know. That's a pretty egregious typo, actually. Yeah, that's okay. So 4 is Fatima. Sorry about that. Something in my cut and pasting went terribly wrong. So you're right. 4 is going to be, thank you for saying something. I'm sure everyone was seeing that and really confused. Okay, so, and user ID, man, this just got, all right, that's 1. Sophia's down here. What did I do? That's Sophia. Sophia is number 1 and number 2 is Donald. Okay, let's try that. Okay, that should make more sense. 1 is Sophie, 4 is Fatima, 2 is Donald, right. That's what it should look like. Thank you for pointing that out. So right, so we're joining these two tables together, and we're sort of getting this new sort of virtual table, right, that has columns from both comments and users, and they're sort of lined up so that the user ID from comments matches the ID from the users table. So as you can see, it gives us a nice, like now, instead of just saying, oh, one wrote this comment whatevs, we can see that, oh, that was Sophia that wrote the whatevs comment. So I feel like I'm missing a query in here. So what would this, oh, yeah, no, this is what we're looking at. Okay, so, so what would that query look like? It would look something like this, right? So we could say select comments dot star from comments, and then here's the magic: join users on users.id equals comments.userid. So this is where we're saying, this is the join condition here. When we say join users on, we're saying, okay, I want you to join with the users table, but I want you to match the user rows to the comments table where this condition is true. So the condition that we're checking for is that the ID from the users table matches the user ID from the comments table. Which, because we named the columns sanely, that should seem painfully obvious, right? Of course, that's how we're going to match up those two tables. But SQL does not take for granted that you gave your columns sane names. So you have to get explicit and say, like, these are the two columns that you should match. And in this case, we're adding a filter here. So this is going to allow us to find all the comments that were written by Amy at example.com, for example. And up here in the select statement, if I just said select star in this query, then I would get all of the columns from both of the tables in my results. But if I just want to get all of the columns from the comments table, I can say comments.star. So this allows me to sort of, it's sort of like I'm doing a select star on comments and just magically only getting the comments written by Amy. So I'm sort of, I'm joining the two tables together to get all of those columns, and then doing a filter on one of the columns in the users that came from the users table. But then in my final results, I sort of filter out all of the columns from the users table and just show the columns from the comments table. Any questions on that? Does that kind of make sense? Cool. I'm going to assume that is a yes. Great. Okay, so moving along. So this is what results for that query would look like, right? We see we're just getting the columns from the comments table. We're only getting a couple of rows. We're just getting rows where user ID is 1, assuming that was Amy at example.com's user ID. So let's look at another example. What if I wanted to get all of the posts written by a particular user based on that user's ID? So in this example, let's say I wanted to say, okay, show me all of the posts that were written by the user with ID number 2. So again, I would select posts.star from the posts table, joining my join table. So remember, we had that posts authors table that had a post ID and an author ID in it. So I'm joining the post authors table, and I'm joining on posts authors.post ID, checking to make sure that matches the ID from the posts table. So I'm doing that join, and then my where clause, I'm just filtering on the author ID, which remember points to the users table. So I'm filtering on the author ID, just getting the ones where author ID is 2. So in this case, I didn't actually even have to query the users table. If I already know the ID of the user that I'm looking for, of the author that I'm looking for, I don't even have to join in the users table. I can just join posts with posts authors and do the filter that way. So here's another fun category. So this is, we're going to start looking at group by. So this will be fun. So what if I wanted to get a count of the posts in each category? So remember, posts are all, can be associated with a single category. So the query we're doing here is selecting the categories.name and then something called count star, which I'll come back to in a minute, from categories. And I'm doing this join, which should look really familiar by now. And I'm joining posts with the categories table on categories.id equals posts.category.id, right? So remember, each post had a category ID that points to the category it's in. And then at the bottom here, I'm doing a group by. So group by categories.name. And group by and count here are working together. So the idea here is I'm getting that big table full of results, right? That's going to have it's going to have all of the columns from the posts table and all of the columns from the categories table. And a lot of these posts are going to be in the same category, right? So the same category is going to show up in like category name several times in that result. And so what I'm doing in the group by is I'm collapsing all of the rows that come back that have the same category name. I'm sort of collapsing into a single row. So I'm sort of grouping all of the posts from the same category together. And what group by allows me to do is use a number of different aggregation functions. So this count star is what you could call an aggregation function. So it's basically, it's a function that's sort of computing some aggregate value based on all of the rows that are in the current group. So I can still select categories.name because that's what I'm grouping by. So in my results, I'm going to have a separate row for each category. And the next row, I'm going to have a count that is just the number of posts that are in that category. So my results are going to look something like this, right? I'm going to have all my different categories for legal posts. And then I'm going to have a column called count that is the number of posts that matched that, the number of posts that were in that group, right? Does that make sense? Does group by make sense? I feel like I stumbled over that a little bit. Is that clear, or do y'all want me to go over that again? Oh, maritime law. I totally should have used maritime law. That's what I get for rushing. So that's group by with count. So the other thing we could do here is add an order by. So right now we got our categories, they're just kind of coming out in this random order, right? If we wanted to, say we were displaying this on a page, right? We might want to display the categories for the, so imagine like you had your left nav on the front page of your blog site, right? And you might want to list all of the categories with the number of posts in each category right next to it, right? So that first query would be nice for that. But it kind of makes sense if the categories were ordered in some like reasonable way. So one way we might order them is alphabetically. So all the categories show up alphabetically. So we can add an order by clause to our query that'll order the categories by name. And so we'll get it this way, right? Where they're now here alphabetically. Another more interesting thing to do might be to order by count. So now that we have this count can be treated just like any other column in our result. And so among other things, we can order by count. So if we order by count, we'll get all the categories ordered by how many posts are in that category. And you'll see that this is in ascending order. So the lowest counts come first, and then the higher counts come after it. So if we wanted to flip that around to show the bigger categories first, we can just add a DESC keyword after our order by. So it stands for descending, right? Order by count descending. And that will order by count, but in descending order, where the biggest stuff is first and the smallest stuff is last. So that just kind of flips it around. And one thing that's really helpful to do with order by descending is a nice way to get the largest of something. So if we add on to that query one more piece and say limit 1, this combination of order by count descending and limit 1 is going to put the largest category first, and then limit 1 is going to say, just give me that first row. That's all I care about. And so this is a nice way to just get, like, if you want to figure out what's my most popular category, this is how you would do it. Join into posts and get the categories.name, group by category name, order by count descending, limit 1. All right, so let's move on. So finally, this is probably the most complicated thing we'll do today is get all posts by a user given their email. So we did this earlier when we were assuming that we had the user's ID already. If we don't have the user's ID, we just have the user's email, we're going to have to join 3 tables together to get from the user's table where the email is stored all the way over to the posts table where the post data is stored. Excuse me. So that's going to look like this. We're going to select posts.star. And again, this is just assuming that the only data we care about is the columns from the posts table. We could certainly add columns from the users table in here if we wanted to from our select. But we're selecting from posts, and then we're doing this first join, which we saw before, join posts authors on post ID equals post authors.post ID. So there's that join that we're familiar with. And you can do as many joins as you want. You just keep on going and say, hey, let's join in another thing. So at this point, after the first join, you can sort of imagine that we have that combined table that we saw earlier. Let me get up here, right? So we've joined 2 tables together, and now we have this sort of like virtual table that has like twice as many rows. It's this big fat table, right? And so when we do another join, now we're basically taking this table that's on the bottom and we're joining that to another table. And so the process looks really similar. Let's get back to, here we go. So now we're saying join users on posts authors.author_id equals users.id. So we're joining in that 3rd table. So now we have this really wide table that has all the columns from posts and posts authors and users all together. And so now we can filter that and say where users.email equals amy@example.com, right? So we just get Amy's rows. And then the select will sort of chop off all the columns from these other 2 tables that we joined in and leave us just with the posts columns for all of the posts that were written by the user with email address amy@example.com. And that's one of the slightly unintuitive things about the way SQL is written is that when you're writing a SQL query, you always start with select, and then you do some joining, and then some filtering at the end with a where clause. But the way this query gets resolved, the select is actually the last thing that happens. So first, the database is going to go and it's going to join all these tables together and filter out the appropriate rows. And then at the very end, it's going to take that huge data set and lop off any of the columns that you don't need. Conceptually, you can think of it doing that way. In the internals of the database, it may be doing some optimizations along the way and throwing away columns that it knows you're not going to need later. But in terms of like conceptually what's happening, you can think of the select as happening at the end. Excuse my coughing. So let's see. So this is kind of the results we would get back from that with the bodies of the posts truncated. Yeah, okay. And that's everything I'd planned to go through. But we've got time left over for questions. I've put together just a little repository that has all of this, all the schema statements that could create table statements in a file, and then another file that has just like a bunch of dummy data to fill in to that schema. And I will post a link to that after this. And I'll also put it on the YouTube comments. When the video gets posted to YouTube, it should be in the description there. So y'all can check that out if you want to, and like create a database that has this schema with some data in it, and like practice doing these different types of queries and sort of play with it yourselves if you like. Hopefully that will be a helpful resource. And because I have that loaded up here too, we could play around with it. If there's other queries you wanted to experiment with, I can open up a console and we could play with it some here.
I have 2 things.
Yeah.
Can you hear me?
Yes.
One, will you add maritime law to the slides?
I will make a note to myself
Okay.
and add
then
maritime law.
two, we're just using general join. I know we had to learn everything about like the types of joins, but
Mhm.
do we actually have to specify that in queries?
Yeah, so the type of join that we're doing here, when you just say join whatever, and you don't give it like left, inner, outer, right elbow join, technically what you're getting here is a left inner join. So for those of you who studied inner and outer joins and right and left, and what you're getting by default here is what would be technically called a left inner join. And that's just a fancy way of saying that, let's go back to one of these queries. It's just joining two things. So, so in this case, when I'm saying join posts on categories.id and so this join statement here, because this is a left inner join, the behavior is going to be, the difference between an outer and an inner join is basically how the database is going to respond to the situation where there are no matching rows in one or the other of the tables. So you can imagine a situation here where there's a category that has no posts in it at all. So as the database is going through and trying to join rows from the posts table to the categories table. So for instance, if I went in and added maritime law to the categories table right now, I don't have any posts in maritime law yet. So when I ran this query, the database wouldn't be able to find anything to match for that maritime law row in categories. And in that case, because I'm just saying join here, the database is just going to leave out maritime law from the results because there's nothing to join it from. Wait.
It would really only show up on like the category table if you added it, right?
Yeah, actually, I'm sorry. I misspoke. Let's, instead of me pontificating here at a slide, put this in a console, and we'll do that. Let's say select star from categories. Okay, so there's my categories. I can insert into categories name maritime law. Maritime law column, oh, single quotes. Duplicate key violates.
Hey, Trevor.
Yeah.
We can only see the slideshow. We can't see what you're typing at all.
Oh, thank you so much. I forgot that I'd done the share that way. Hang on a sec. Okay, so insert into categories, name, values, maritime law, duplicate key. ID 2 already exists. I don't know what's going on there. Let me get specific here. Give it an ID of 6. Okay, there we go. So, so now we have maritime law. If I run this query from here, copy. So you can see I ran this query here with the join, and maritime law doesn't show up in here because there's no match. There are no posts that show up in maritime law. So instead of getting maritime law here 0, I just get nothing. And that is the upshot of doing this join as a called a left inner join. So left basically means that like, yeah, it's going to leave out the rows from the. It's going to leave out the rows that don't have a match. Now I could say count star from categories. Count star from categories join posts on. And since I'm doing this in the console, I'm going to use abbreviations here. So one nice trick is that you can rename tables in a query so that when you reference them in other places, you don't have to type them all out again. So I can say categories as C and posts as P, and then let's be say P dot ID equals C dot posts ID. Group by C dot name. No. Post ID. And post ID is not categories dot. Oh, sorry. C dot ID equals P dot category ID. There we go. Okay, so here's that join query again. So if I change this to an outer join, no. So the thing to learn here, right? Outer join, full outer join. There it is. Right. So if I do a full outer join, that's basically saying like, I don't care if there are like things that don't match. Include all of the rows from the first table, even if there are no matches in the second table. And that's why we see maritime law show up here. And it has a count of 1 because there is 1 row in the result now. If we take this group by off, we can see that. If we take this off and the, just say post.id. So here you can see that we're getting, you know, we have 3 rows that come back for immigration law because there's 3 posts in there. But maritime law and family law, there is a row. There's just no ID. There's no post ID there because there was no matching row, but they still show up in the results. If I change that back to just a regular join, those will go away. I know left outer and inner joins and all that can be confusing. What I will say is it's good to know. It does come up some, but honestly, in 10 years of doing this, I've rarely ever had to do anything other than a normal join. This is almost always what you want, just the regular join. So if you know this one, you're 90% of the way there. Great question. Other questions? Hey, is somebody asking a question? It's really quiet. I can barely hear you.
You said we don't actually end up needing to label them as inner and outer joins, right? So we wouldn't need to label them as such?
Yeah, so just by saying join here, you get the default behavior, which is what we saw, which is an inner join.
Well, I meant in the queries on the slide.
Yes.
So we have an idea conceptually of which ones are which.
Gotcha.
Mm-hmm.
Yeah, so all these, so in where are my queries?
That'd be awesome to know.
Yeah, so in Postgres, if we look up join between tables, let's pull up the documentation here, just so that I make sure I'm saying this exactly the right way, because even I get the words confused. Joins between tables. Where is it? Right, so by default, you're getting an inner join here. That's what the words, Trevor. That's what when you just say select star from something join, it's the same as saying inner join. So all of these in the slides that we've been looking at are inner joins. Does that make sense? And an inner join is what you're going to use most of the time. All right. Okay, well.
Hey, Trevor, I have a question.
Yeah, sure.
So when you ended up doing that outer join and you got maritime law, and when you did the count all further up, Why did it show up with a count of 1 as opposed to count of 0?
That's a really good question. So let's, let me go back to this here. So if I change this to a outer, sorry, full outer join. So when I change this to a full outer join, so not doing the, this was without the group, right? So I'm getting p.id. Maybe it'd be helpful to show, well, we'll just start with that, right? So we can see here that like in the results without the grouping, I have 10 rows in these results, right? I have, I've got 2 tort laws, I've got 2 criminal law rows, I've got 3 immigration laws, I got a Jude law, and I got maritime and family. So there are 10 rows in these results. And if I group these rows together, if I just count the rows that have like the same category name, I will see 1 row for maritime law and 1 row for family law. And so when you're doing a group by, and let's change this to count. So when you add the group by in there, the count is just counting rows. And because we did an outer join, that row does show up in our results. So it's going to get counted, even though some of the columns were null, right? The post ID column is empty here, but the row still exists and the row still gets counted, even if some of its columns are null. Does that make sense?
Yeah, it does. Thanks.
Okay. Sounds good. All right, well, we are about at the hour, and I'm getting calls about my kids at daycare, so I should probably go and see what that's about. But thank you all for coming and having good questions. I will get the slides posted and the repository posted with like the code for this so you can play with it. And feel free, if you still have questions, hit me up in Slack this afternoon and we can continue to talk about it. Enjoy the rest of your Wednesday.